Hi, today we will learn vacuum circuit breaker. Vacuum circuit breaker use vacuum as arc quenching medium. In this circuit breaker, the fixed and moving contact is enclosed in a permanently sealed vacuum interrupter. It is mainly used for medium voltage ranging from 11 kV to 33 kV. Vacuum circuit breaker is generally not preferred for applications beyond 33 kV. You might be wondering, if VCB works so well at lower voltages, then why are they suddenly avoided above 33 kV? There are certain limitations that makes them unsuitable beyond 33 kV applications. We will discuss these limitations at the end of the video. Now, we will learn construction and working principle of vacuum circuit breaker. It is very simple in construction as compared to any other circuit breaker. Their construction is mainly divided into three parts: fixed contact, moving contact, and arc shield, which is placed inside the arc interrupting chamber. The fixed and moving contacts of the breaker are placed inside the arc shield. An arc shield is a component that prevents metal vapor coming out from the arc on the outer insulating envelope. Therefore, it is also called as vapor condensation field. The outer insulating envelope of vacuum circuit breaker is made of glass because the glass envelope helps in the examination of the breaker from outside after the operation. If the glass becomes milky from its original finish, then it indicates that the breaker is losing the vacuum. The metallic bellows made of stainless steel is used to move the moving contacts. The design of the metallic bellows is very important because the life of the vacuum circuit breaker depends on the ability of the component to perform repeated operations satisfactorily. The pressure in a vacuum interrupter at the time of sealing is kept about 10 raised to minus 7 to 10 raised to minus 5 torrent. The moving contact of the circuit breaker are moving through 5 to 10 mm depending upon the operating voltage. Now we will see working of vacuum circuit breaker. At the time of normal operating condition, fixed contact and moving contact are closed. When the fault occurs in the system, the contacts of the breaker are moved apart. When the moving and fixed contact detach, their entire surface do not separate simultaneously. During separation, the contact surface area gradually reduces before the contacts fully separate. As the contact area decreases, the current density increases at that point, creating a hot spot. At this hot spot, the contact metal vaporizes. So when the breaker contacts separates, an arc forms due to the ionization of the metal vapor released from the hot spot on the contact surface. This arc is essentially a plasma bridge that temporarily sustains current flow, even after the contacts has separated. The density of vapor depends on the current in the arcing. In alternating current waveform, at the time of decreasing mode of current wave, the rate of release of vapor also decreased. After the current zero, the medium regains its dielectric strength and vapor density around the contact reduces. Hence, the arc does not restrike again because the metal vapor is quickly removed from the contact zone. Now, we discuss advantages of vacuum circuit breaker. Vacuum circuit breaker does not require any additional filling of oil or gas. Also, they do not need periodic refilling. Vacuum circuit breaker rapidly recovers its high dielectric strength, which is within only a half cycle of current waveform. Breaker unit is compact and self-contained. It can be installed at any required orientation. Because of all these reasons together, with the economic advantage offered, vacuum circuit breaker is highly preferred for the voltage between 11 kV to 33 kV. Despite all these advantages of VCB, there are certain limitations that make vacuum circuit breaker unsuitable beyond 33 kV applications. For very high voltages, the required gap increases significantly because dielectric strength is proportional to the contact gap. So, at very high voltage levels, the gap size becomes very large within a range of several centimeters, which makes the interrupter design bulky. The large contact gap requires a long travel distance for the moving contacts. Covering this long travel distance within the first 2 to 3 cycles of current is also a challenging. VCB interrupt current by extinguishing the arc in the vacuum, which works well for moderate fault current, that is up to 40 to 63 kiloampere. But in very high voltage systems, fault current can be much higher, which is around 80 to 100 kiloampere. While interrupting this level of high fault current, it can create a high transient voltage across the contact. The vacuum interrupter struggles to quench the arc and withstand the steep transient recovery voltage at these levels. Therefore, it may increase the risk of restriking of arc, or it may fail the final interruption of arc. The cost of manufacturing vacuum interrupters and the overall switchgear increases significantly with higher voltage levels. For high voltage applications, technologies like SF6 field circuit breakers become more economical and practical. Maintaining a permanently sealed, high-quality vacuum becomes increasingly difficult and costly with higher voltages, as the potential for leaks or degradation of the vacuum increases. Due to all these limitations, for the systems operating above 33 kV, SF6 circuit breaker offer a more reliable and cost-effective solution. Because SF6 gas has superior arc quenching capabilities and higher dielectric strength than vacuum at high pressure. SF6 breakers are effective across a wide voltage range, that is from 33 kV to 800 kV, and provide better performance in very high voltage systems. If you want to learn SF6 circuit breaker in detail, then watch my video of SF6 circuit breaker. Link is available in the description box. This is about vacuum circuit breaker. I hope you understand why VCB not preferred above 33 kV applications. If you found this explanation useful, don't forget to like, share and subscribe. And let me know your thoughts in the comment box. Till time, keep learning, keep growing. Thank you.